In this video, I am going to cover a couple more problems from classwork 1.3. I'm going to do numbers 46 and 49, and hopefully once you've watched me perform those, you can go ahead and try number 50, which is a little bit more of a challenging problem as well. Okay, so number 46, we're doing classwork 1.3. Number 46 is the problem where we drop something past a window. So it says a fallen stone takes 0.3 seconds to travel past a window that's 2.2 meters tall. From what height was the stone dropped? So for these types of problems, I like to draw a picture to help me sort of clarify the scenario, right? So I have my window, okay, and I know that I'm told that this is a displacement of negative 2.2 meters. So that's a D going down. And I also know that my time there is equal to 0.3 seconds. All right? Now, somewhere above, okay, there was the stone dropped to get to this point so that it could go past the window and be seen. So our actual question is what is that D? Right? What is that displacement? Okay? Some things that we know from up here is that if it was dropped, the initial velocity up there is going to be 0 meters per second. And I know acceleration is equal to negative 10 meters per second squared. Okay? So what we need to solve for this D is we need velocity final, because what that would make it so that we could use this equation, Vf squared equals V initial squared plus 2AD, okay? And we could solve for D if we had Vf, but we don't have Vf, okay? So we want to know what is this velocity here, okay? If we find that velocity out, then we can solve this problem, okay? So now let's look at the bottom half. Okay, so we're going to ignore this up here, and we're going to look at the variables that we have here. And now this is our question. In this scenario, this is actually V initial. Up there it's V final. Down here it's V initial. That's perfectly fine. Okay, so we really want to solve for V initial in the bottom half. We have D, we have T, and we also have, negative 10 meters per second squared for gravity. Okay, so we have A as well. Okay, so given that you have these, right, we should be able to solve for V initial. Okay, using D equals V initial T plus 1/2 AT squared. Okay, so we just plug and chug. Negative 2.2 equals V initial, that's what I'm solving for, times 0.3 plus 1/2 of negative 10 times 0.3 squared. And if I plug that all into the calculator and I solve for V initial, let me see what I got here, 5.8 meters per second, or negative 5.8 meters per second. Okay, so this is my velocity right here. For the bottom half of the problem, we call it V initial. For the top half of the problem, we now call it V final, right? We define the parameters of our scenario. As long as we're doing it accurately, it's fine. So now I have everything I need to solve this. So I just plug in here, negative 5.8 squared equals 0 plus 2 times negative 10 times D. And if I solve that, I get D equals negative 1.7 meters. Negative meaning that the ball or the rock had dropped 1.7 meters. So we would say that the rock was dropped from 1.7 meters above the window. All right, let me go ahead now and do number 49. So this one's even a little bit more complicated. In this case, it says a stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff that's 75 meters high. How much later does it reach the bottom of the cliff? That's the first part of the question. There's 3 parts. Let's just start with the first. All right? So I'm going to draw a picture that then shows the scenario, right? So someone's up here and We throw the rock up in the air. Okay? And I know that the height of the cliff is 75 meters. So my displacement, because I started here and ended here, is actually equivalent to the height of the cliff. So that is negative 75 meters down. Okay? I know that my initial velocity here is 12 meters per second. Okay? I know that right up here, my velocity is, well, I won't call that velocity initial. We'll just call it velocity t, like velocity at the top, is 0 meters per second. Okay? And then, of course, we always have acceleration, which is negative 10 meters per second squared. Right? So the first question says, how much later does it reach the bottom of the cliff? So we're trying to solve for time. Time is our question. Okay? I have V initial, I have D, and I have A. So I can solve for T using this equation. D equals V initial T plus 1/2 AT squared. Now it's going to kind of be a pain because it is a quadratic and there's two T terms in there, so I'm going to have to use the quadratic formula. But it just takes a little bit longer, right? So let's plug in. We got negative 75 equals 12T, and I'm just sort of ignoring the units now so you can just see it. 1/2 of negative 10, so it would be minus 5T squared. Okay? Now, remember when we do the quadratic, we need to set it equal to 0. So 0 equals 75 plus 12t minus 5t squared. This is A, this is B, and this is C. Okay? I'm not going to go through the entire quadratic equation. You should all know that by this point. If you haven't done it in a while and you just want a refresher, ask me in class and I can help you individually with that. But when you solve for the t term, remember you always get 2 when you do the quadratic. You get a negative 3 seconds or 5.3 seconds. Okay? Time is not negative, it's a scalar. Okay? So our answer is 5.3 seconds. Okay? Now the next part of the question says, what is its speed just before it hits the ground? Okay? So we want to know what is the velocity down here. We'll call it V final. Okay? That's our question mark. Okay? Now that we have the time, this becomes very easy. We've got the initial velocity, we've got the final velocity, we have acceleration, we have time. Okay? So we have that acceleration equals the change in velocity over time. We don't even need to use one of our derived constant acceleration equations. We want to solve for V final. That's what we're going to be calculating for. So multiply by t, you get AT equals VF minus V initial. And then add V initial to both sides. Get AT plus V initial equals VF. Okay? Plug that in. I get negative 10 times 5.3 plus 12 equals, without a calculator, we've got negative 53 plus 12. That gives us negative 41 meters per second. So here I'm going down at a rate of 41 meters every second. Okay? Now, the last part of the problem says what total distance is traveled. Okay? So keep in mind, this is the displacement, the change from the original position. The distance is going to be this plus this plus this. Okay? So we're going to separate it into those three parts, right? So we know this, okay, is 75 meters. So we have 75 meters, right? We know that this and this height, and we're just kind of ignoring the angle, are equal to each other, okay? So all we really need to do is find out this height, and then we have this height, okay? I'll redraw it down here since I'm kind of running out of room, right? So I have it flying, let me put it over here. You have it flying up some height, and then down some height that are equivalent to one another, and then another 75. right? I know that my initial velocity right here is 12 meters per second. And remember, up at the tip top, zoom in a little bit here, up at the very top, it is 0 meters per second. Okay? So all I need to do is calculate one of these, and then the rest will be really easy. Okay? So I'm going to use VF squared equals V initial squared plus 2AD. My V final, this would be my V final because this is where I started and this is where I'm going to end. So my V final will be 0. My V initial is 12 squared plus 2 times gravity, which would be negative 20, right, D. Okay, so I end up with 144, and we're going to subtract it. So 144 equals negative 20D. Okay, and 140 divided by 20 is roughly 7. It's actually, if you plug it into a calculator, 7.2. Okay, so this is 7.2 meters, and this is 7.2 meters. So now all I have to do is take my 7.2 plus 7.2 plus 75, right? So 75 plus 7.2 meters plus 7.2 meters, and my total distance that I get is 89.4 meters. Okay? So hopefully by watching these demonstrations of a little bit more challenging problems, you can go and try number 50, which is a level 3 question. It's one of the harder questions as well.